Hello viewers, welcome once again. We are still under logic, Christ Almighty, God's Algebra. Last tutorial we treated the Morgan's law by conjunctive statement. In this tutorial, we're going to treat the Morgan's law by disjunctive statement. Let us start. The Morgan's law. Not bracket P and Q is equal to not P or not Q. This is an example of De Morgan's law by disjunctive statement. If you look at this equation, you find that it is logical equivalent. That means whenever the left answer of the equation is true, also the right answer of the equation must also be true. In the same vein, whenever the right answer of the question is false, also the left answer of the question must also be false. We say it is logical equivalent. So we are going to prove that this statement is true. Why is it called De Morgan's law by disjunctive statement? Is because this or corrective that combines this not P and G not Q together as a single statement. So we call it, because of it is operative that combines them together, we call it conjunctive statement. So it becomes De Morgan's law by conjunctive statement. So let us prove the statement that it is De Morgan's law. Proof. Suppose not bracket P and Q is equal to not P or not Q. We assume that the statement is true. We assume it is true and is our hypothesis. Since it is true and is logical equivalent, so we are going to transform it to biconditional statement. That is to say, if and only if not bracket P and Q is equal to if and only if not P or not Q. We have now transformed it to biconditional statement. And whenever the left equivalent is true, also the right equivalent must also be true. In other way around, whenever the right equivalent is false, also the left equivalent must also be false. So whenever I want to evaluate this statement, there's no possibility of getting falsity, always truth. If that is the case, we say the statement is tautology. So if this is true, this also must also be true. Say is tautology being justified by logical equivalent. Say if and only if. Now see, this is tautology. This biconditional statement is tautology. We are going to transform it to conditional statement, and it will still preserve tautology. That is to say, not bracket P and Q implies not P or not Q. And you see that when if antecedent is true, also the consequent must also be true. So if that is case, there's no possibility of getting falsity when you want to evaluate this statement, always truth. You say that the statement is tautology. Since when you evaluate this statement, there's no possibility of getting falsity. We then say the statement is tautology. Is tautology. We see that it still preserves it still preserves tautology. Being justified by logical implication. Being justified by logical implication. See, if and only if, since the statement is tautology, this conjunction statement is tautology, there's no possibility of getting falsity when you want to validate the statement. We then deduce for sure that antecedent exists. It is for sure the antecedent exists. That means it is a proper implication of not P or not Q, the consequence. Since it exists, we say that not bracket P and Q, that means the antecedent, is logical implication of the consequence, not P or not Q. Not bracket P and Q is logical implication of not P or not Q. Since it is logical implication of not P or not Q, if it is true, if this is true, also this must also be true. See, if and only if not bracket P or P and Q is equal to not bracket P and Q. That means the logical implication is equal to itself. And if it's equal to itself, you say that it is logical equivalent. And it is true that it is logical equivalent because whenever the right hand side of the logical implication is true, also whenever the left hand side of logical implication is true, also the right logical implication must also be true. In the same vein, whenever the right logical implication is false, also the left logical implication must also be false. We say that is the case that it is logical equivalent and it is true. Being justified by identity, the sameness. By identity. Since this is true, this also must also be true. Say if and only if not bracket P and Q is equal to not bracket. Now we are going to this statement P and Q, we are going to transform it to conditional statement by Christ Almighty God's grace. That means we are going to have Q upon not P. We have now transformed it to conditional statement using Christ Almighty God's grace. Now you see that the statement is no more equal. The left hand side equation is now greater than the left hand side of the left hand side equation now is greater than the right hand side equation in value. So they are no more equal, it's not grace. So it's no more equivalent. That means law, it's no more law, it's not grace. Because one is not subset to each other. Other one is subset to each other. You say it is grace. So you see that the right the right hand side of the equation is now a subset, it's now lesser in value to the left side of the equation. You say it is extenuation of not P and not bracket P and Q. That means not bracket Q upon not P is extenuation of not bracket P and Q. Is extenuation of not bracket P and Q. Being justified by Christ the Almighty God's grace. So if and only if not bracket P and Q is equal to, we are going to simplify the conditional statement. That means not P implies Q. We are going to simplify it. That will be Q upon not P. So anyone that is positive becomes negative, anyone that is negative becomes positive. That to say that we have not Q upon P. Now we see that statement now, this equation now has become equal. It's now logically equivalent. It's now equal to the other side of the equation. So it's being justified by simplification of law. By simplification of law. So if and only if not bracket P and Q is equal to. Now we are going to revise this conditional statement to disjunctive statement. Reason is that here this not P, the implication, is being generated from the conditional statement. But later on it is signified. It becomes P. The implication becomes no more not P, it becomes P by signification. So when you want to revise it, you're going to be in form of disjunctive statement since it is signified. Since it is signified, and it becomes no more negative P, but positive P. The way you want to revise it is going to be not in conjunctive statement, like going to be in disjunctive statement. That is to say, we have not P or not Q. Being justified by first educate law. By first educate law. Because we transform this not Q upon P to not P or not Q to disjunctive statement through first educate law. So we have now proved the statement that not bracket P and Q is equal to not P or not Q. We then say thus not bracket P and Q is equal to not P or not Q. Since statement is law, since statement is law, we are going to prove also the compass, so that by principle of externality, we then establish that not bracket P and the Q is equal to not P or not Q is De Morgan's law. So conversely, not P or not Q, not P or not Q is equal to not bracket P and the Q. We have seen that we have now conversed the statement. Here, not bracket P and the Q is at the left side of the equation here, but here it becomes at the right side of the equation. Here, not P or Q is at the right side of the equation here. Here, it becomes at the left side of the equation here, not P or not Q. So it is the converse. So you want to prove that converse is also holds. So you say that suppose not P or not Q is equal to not bracket P and the Q. So we assume that the statement is true. We assume that the statement is true. So if it is true and it's also our hypothesis, we'll continue to this side. Say if and only if we are going to see the statement is logical equivalent. That means whenever the left side of the equation is true, also that expression must also be true. In the same vein, whenever the right side of the equation is false, also this expression must also be false. You see, it's logical equivalent, and it is true that it is logical equivalent. So if it's not equivalent, we are going to transform it to biconditional statement. That to say, if and only if not P or not Q, if and only if not bracket P and the Q. If I transform it to biconditional statement, I see that whenever the left equivalent is true, also that equivalent must also be true. Also, in the same vein, whenever the right equivalent is false, also the left equivalent must also be false. So when you want to break the statement, the statement is logical equivalent. It's also it's tautology. So whenever you want to break it, there's no possibility of getting positive in this statement, always truth. In that case, the statement is tautology. Is tautology being justified by logical equivalent. Now, since this statement is tautology, this biconditional is tautology. We can also transform it to conditional statement, and we shall still preserve tautology. Say if and only if not P or not Q implies not bracket P and the Q. You find out that when if antecedent is true, also the consequence must also be true. So whenever I want to break the statement, the possibility of getting falsity always truth. We say that statement is tautology. Is tautology being justified by logical implication. Being justified by logical implication. Since this statement this statement is tautology. We then deduce for certain that not P or not Q exists. And if it exists, we say that not P or not Q is logical implication of not bracket P and Q. So if and only if not P or not Q is logical implication of not bracket P and Q. So if and only if this is true, this also must also be true. So if and only if not P or not Q is equal to not P or not Q. That means the logical implication is equal to itself. And if it's equal to itself, it is logical equivalent. And it is true that it's logical equivalent. Because whenever the left hand side of the implication is true, also the right hand side of the implication must also be true. In the same vein, whenever the right side of the equivalent, the right side of logical implication is false, also the left side of equivalent, left side of the logical implication must also be false. If that is the case, we say that the statement is logical equivalent, being justified by identity, the sameness. Being justified by identity. You continue to this side. So if and only if not P or not Q is equal to. Now we are going to transform this duty statement to conditional statement. That means we are going to have not Q upon P, and it still preserves logical equivalent. So it is still logical equivalent. That means it's law. It never changed to grace. So being justified by first edge case law. By first edge case law. We continue. Say if and only if not P or not Q is equal to. Now we're going to simplify not Q upon P. To simplify it, so anyone that is positive will become negative. Anyone that's negative will become positive. That will say we have not bracket Q upon not P. Now we see that the segment has been now excavated. The right side of the equation now has now become less value of the left side of the equation. That means it has now been excavated. So it's no more equal to the left side of the equation. Rather, it is now a subset of the left side of the equation. While the left side of the equation now is not subset, it's not superset of the right side of the equation. You say that it is extension of the left side of the equation. You say is extenuation of not P or not Q. So being justified by signification of law being justified by signification of law. Say if and only if not P or not Q is equal to not bracket. Now we are going to this statement, this Q upon not P, we are going to revise it. The question statement, we are going to revise it to disjunctive statement. Sorry, we're going to revise it to disjunctive to conjunctive statement. Why we're going to revise it to conjunctive statement is because it is this disjunctive statement here that generates the implication P. So further signified, it becomes not P. So when you want to reverse it, it's going to be in conjunctive statement because it started from disjunctive statement. So it ends with disjunctive. It started with disjunctive statement, it's going to end with conjunctive statement because it's signified. So we are going to have P and Q. You have now been justified by Christ the Almighty God's grace. So we have now proved the converse. That means not P or not Q is equal to not bracket P and the Q. We have now proved the converse. We then say thus not P or not Q is equal to not bracket P and the Q. Since I have now proved the converse, by the principle of essentiality, we then established or conclude that not bracket P and Q is equal to not P or not Q. Not P or not Q. So therefore, not bracket P and Q is equal to not P or not Q is De Morgan's law. We have now proved De Morgan's law by disjunctive statement. So at this juncture, we draw our curtain. Thank you, viewers.